next question is a linear equation and an initial value problem for a linear equation. Well, although the equation is linear, so notice that the coefficient at y prime is not 1. But in order to find an integrating factor, we always need to put it into the form where the coefficient at y prime is 1. Right? So which means that, well, what we've got to do, we've got to divide everything by t. So then t is cancelled out with t at y prime, and then the coefficient at y prime will be 1. So by doing this, we are rewriting this in this form: y prime plus 2 over t y equals, we're dividing this by t, so it's t minus 1 plus 1 over t, right? And now it becomes clear why we have this requirement that t is positive, and because now in our differential equation we have some terms where there is division by t. So if t were equal to 0, then we cannot divide by 0, so which means that we have to exclude the case when t is 0, and if t is not 0, then either t is positive or t is negative. So here we are just given that, okay, so let's do it for positive value of t. Well, now we need to find the integrating factor. So what is the integrating factor? So this is the integrating factor, mu of t is e to the power antiderivative of the integral of the coefficient at y. The coefficient at y is 2 over t, and then we've got to integrate it. Now, let me continue. 2 over t. So the antiderivative of 2 over t is 2 ln t. So notice that I did not use ln of absolute value of t because we are given that t is positive. Okay, so what is this? We can kind of rewrite it as e to the power ln t and times 2, which is e to the power ln t squared, and e to the power ln t is just t, so we have t squared. So the integrating factor is t squared. So now we've got to multiply our differential equation. So remember that we've got to work with the one that has coefficient 1 at y prime. We've got to multiply it by the integrating factor, which is t squared. Okay, so let's do that. T squared plus t squared times 2 over t is, sorry, I forgot y prime. So y prime plus 2t times y equals, we are multiplying t by t squared, so then t cubed minus t squared plus t. Okay, so now the whole point of doing the integrating factor is that now the left hand side of our differential equation becomes t squared times y, everything, the product is prime, right? It's the derivative of the product. This is t cubed minus t squared plus t. Well, so the derivative of this function t squared times y is the given function, so t squared y is the antiderivative, is t cubed minus t squared plus t dt, which is the antiderivative of t cubed is 1 over 4 times t to the 4 minus 1/3 t cubed plus 1/2 t squared plus constant. Right? Okay, and then as I said, for linear differential equations, it doesn't really matter when you use your initial condition to solve for c, so you can as well solve for y first. So let's do that. To solve for y, we need to multiply this whole thing by 1 over t squared. So then this t squared is going to cancel with t squared at y. Then we're going to get y equals, so remember that we are dividing by t squared, so we have 1/4 times t squared minus 1/3 times t plus 1/2 plus c over t squared. This is the general solution, and we've got to find to use the initial condition to solve the initial value problem. Okay, so let's use the initial condition to solve for c. So y of 1 equals 1/2. Now y equals 1/2 equals 1/4 minus 1/3 plus 1/2 plus c. Okay, cool. So 1/2 plus 1/2 cancels out. So our c is what is 1/3 minus 1/4, which is 4 minus 3 over 12, which is 1 over 12. So therefore the final answer is y equals 1/4 t square minus 1/3 t plus 1/2 plus 1 over 12 t square. So this is the final answer.